about the definition of a function last time, and there was a lot going on here. But essentially, it's a simple topic, right? Instead of writing a function as y equals something, we're writing it as f of x equals, and that's basically the main difference here, okay? So we talked about function notation, which we did on our quiz. Then we started talking about domain and range, right? And essentially what this was is the domain was asking, what can I plug into the function? So what are the x-axis or x-axis values that can plug into the function and come up with a result? So where on the x-axis is there a picture? And the range was the opposite, right? It was all the y values that you could, that the function clicks on. How high up or down does the function go? Okay, we did some examples with pictures of functions, which I think is pretty intuitive when you look at it. I know the piecewise functions get a little confusing. Then we started talking about actual functions where we don't even have to necessarily graph something to find the domain. Then I started talking about, okay, there's two things that really mess up the domain and make it not all real numbers. And I said square roots and denominators were things that kind of made things a little bit more tricky. Okay, so, oh, by the way, is there anyone who needs the guided notes? It's the same one. Okay, so we started with the idea of the square root. And when we're talking about the domain, we realized that you can't plug in a negative number into a square root, right? Because that would give you an imaginary number. So when we did square roots, we said, okay, the inside of the square root has to be bigger than or equal to 0. It can be 0, because you can take the square root of 0, but you can't be anything less. And that's kind of how we did that. Okay, so we did a little example, and I want to go through another one before I let you on your own. Okay, and this time we don't even have a graph. So we're not given the graph. We're not given anything. We just want to find the domain and all the range while we're at it. Okay. So let's see. Let's do the domain first. Okay. And let me move. I want to do this color now. Okay. And when we're looking for the domain, we want the inside of the square root to be bigger than or equal to 0. Okay, so the inside bigger than or equal to 0. Now there's a lot of stuff going on in this function. What is the inside of the square root here? Yeah, 4 minus x. Even though there's a lot of stuff in the function, the thing that's inside the square root, or the thing that's causing the issue, is the 4 minus x. Okay, so this guy here, the inside of square root can't be negative, so it has to be greater than or equal to 0. Okay. Getting x by itself, I guess we need to subtract 4 on both sides, right? So we're left with negative x is greater than or equal to negative 4. How do I get x by itself? We just subtracted 4, but what will we do after that? Sorry. Divide by negative 1. So we get x and 4. What do we do to the sign? Flip it, right? When we divide by a negative or multiply by a negative, we flip the sign. So it looks like that. Okay. So in set builder notation, can someone tell me what the answer would look like? How would I write this in the bracket parentheses notation? Good. And would negative infinity get a bracket or parentheses? Parentheses. And what would 4 get? Bracket. Good, because we're including 4. Okay. So basically anything less than 4 works. Anything bigger than 4 doesn't work. Okay. Now the big question is, okay, finding the domain was all right. How do I find the range, right? Okay. Now, oh yeah. Oh, we could do that. So let's just do that real quick. So we had 4 minus x is bigger than or equal to 0. Yeah, we can add x to both sides. That's totally good. So let's do that. That would give us 4 is greater than or equal to x. I guess that would work a little bit easier, right? But that's the same answer, right? Oh, you're good. Yeah, that would be totally fine. Looks like that would be an easier thing to do, wouldn't it? All right. Either way would be fine. Okay. For questions on tests and quizzes, I'm mainly going to focus on the domain. Okay, so that's kind of what I would focus on when studying. Just because we're dealing with range, let's find it. If you're a little bit shaky on the range, don't worry. But this is how we would find it. Okay. Easiest way to find the range is just to draw a picture, see what happens. Okay. Now, I don't know how to draw this graph. So I guess the only option I have here is to maybe plot some points. Okay, so maybe we have our x values and our f of x values. Okay. But then the big question is, okay, what x values should I plug in? Can I plug in any x value? Could I plug in, let's see, I don't know, 10? Well, we could try it. F of 10 would be the square root of 4 minus 10 plus 2. Would that give me a good answer? No, right? So what sort of numbers should I plug in? So that's less than 4, right? I found my domain. Those are the x values I can plug in. Maybe I should start with my domain and see what numbers in there I can plug in. Okay. Since 4 is like our edge, that must be a pretty important point in our graph. So why don't we plug that one in? Okay. When x is 4, f of x would be f of 4, which would be 4 minus 4 plus 2. Okay. 4 minus 4 is 0, square root of 0 is 0. So this would be 2. Now I need to plug in numbers less than 4. So I guess maybe we should plug in 3, right? 3 is pretty good. So that would give us what? 4 minus 3 plus 2. And I think that gives me 3. Okay. Now I could keep going. And I could plug in 2. Would 2 be a good option for me? Does anyone kind of see why 2 wouldn't work? Yeah, like if I plugged in 2, I would get the square root of 2 plus 2. And let me just write that out. Let's say I plugged in 2. I would get the square root of 2 plus 2, which isn't really a good point. Like I don't know what the number is. I could type in my calculator, but that's kind of crazy. So I'm not going to focus on that. Okay. What do you think the next number I'm going to plug in is? 1 might not work either. 5 actually wouldn't work. A 0 would, right? So if I plugged in 0, that would give me the square root of 4 minus 0, which is 4, plus 2. And that's 2 plus 2, which is 4. Okay. Now you can plug in those numbers, but they might just not give you numbers that you like. Okay, let's try f of 1. And now f of 1 would work, okay? It would give you the square root of 4 minus 1 plus 2. But that's the square root of 3 plus 2. What's the square root of 3? Yeah, you can memorize them, but yeah, I don't really know what they are. So I'm just not going to mess with that, okay? Now, and that's the reason I didn't write it down. Now, of course, you can plug in 1, and that would work. Let me show you why 5 wouldn't work, okay? Let's do 5 now. It would be the square root of 4 minus 5 plus 2. 4 minus 5 is negative 1 plus 2. What's the square root of negative 1? It's just going to be like an imaginary number, right? I think I heard someone say it. But that's definitely just not going to work. So I'm definitely not plugging in anything bigger than 5. You can plug in 1, but that's not going to be useful to us. So I'm not going to do that. So I have enough points. Let me plug them into my graph. I'm going to draw a very basic graph. Maybe I should do this. Okay. It doesn't have to be perfect. I got 1, 2, 3, and 4. And then looks like we got 1, 2, 3, and 4. Okay. At 4, we have 2. At 3, we have 3. And at 0, we have 4. And the square root function always has that weird curvy shape. Okay. I'm going to go back here just for a second. The square root function always has this shape. It could go to the left, it could go to the right, but it's basically half of a parabola. Okay. So based on this graph, it looks like it's going to the left because it's increasing as we read from right to left. So connecting my lines, connecting my dots, it looks like my graph looks like this. Any questions on how I got the graph of this function? Okay. In our next section, we'll actually learn how to graph this square root function a little bit faster than plugging in the points. But for now, we can do this. Okay. So looking at my range, what y values can the function take on? It can definitely take on positive values, right? Because at 3, if I look to the right and left, there is a graph. Any function or any values that the function can't take on? Any y values the function doesn't exist at? 1 is a good one, right? What about 1.5? Yeah, the function doesn't exist when y or when we're at height 1.5. If I look to the right and left, that's not going to work. So any guesses on what the range is? At 5, if I look to the right and left, there is a function, so 5 would work. Yeah, 2 and infinity, right? Because if I start at 2, if I crop this picture at y equals 2 and I just erased everything below it, the function would still be there. We would have the entire function, right? So from 2 up to infinity, the function does exist. Should we include 2? Yeah, right, because there's a closed dot here. So I'm going to put a little bracket here. Okay, and I know that the function exists on the y, on the whole, gosh, the vertical scale from height 2 and up. Okay. Any questions on the range? All right. How about this? I'm going to give you some time to work on example number 14. Definitely want you to look at the domain. If you're feeling wishy-washy on the range, don't worry. I probably won't test you on it, but I will be looking around to see if you are on the right track. Very similar to what we've done before. Let's kind of go over this. So first of all, Robert, you did a good job finding the domain. Do you want to take us through how you got this domain?
Sure. So 70% 6 minus 2x is greater than 0, and then you subtract your 6 from both sides.
Mhm.
That gives you -2 x 6. And then you divide that by -1. Flip the sign, bring them both positive, and divide them by +2, which brings me to x is less than equal to your domain.
Oh, should be.
Bracket.
Oh, sorry. I think it should be a parentheses
Oh,
here.
right.
You're good.
Thank you. Yeah.
And negative, good.
And negative, yes.
All right, very good job finding the domain. I also worked really hard and I made him write the range as well. Do you kind of want to go through how you found the graph and got the range?
Sure. Same thing, sort of. So also after creating that graph, and plug it into the inside. So 6 minus, should be 2, but 6
6 minus.
minus, I'll let you read it. It's there. -2 times is 3, be 0 because 6 minus 6 is 0.
Mhm.
Well, you're getting the square root out, which is 0.
Mhm.
And then going on to the next one, it's 6 minus 4. So it's 2, square root of 2 is 1. And so on.
Actually, I think that might be the square root of 2 here. Yeah, I think 6 minus
Oh.
4 would be 2, but that's okay. Keep going.
I'm mistaken. And then so on for each next one. So from like 1 goes to 2, and then 0 is square root of 6.
Very good. So we're just plugging in some values. Of course, you can get square roots, and that's totally fine. That works on the graph. Now, let me just kind of change up this graph real quick since we got some different values. Okay. Now, in the future, this is why I don't really care too much about drawing the graph, because in the future, you'll have an easier way how to draw these functions. Plugging in points is a little bit, it's up for mistakes a lot. So it looks like we got a 3, 0 and a 1, 2, right? Once we're here and we have 2 points plotted, you actually know the shape of the graph. So you can kind of just connect the dots into what the graph looks like, okay? So you don't need to work too hard to get that graph. Okay. Very nice job, Robert, writing up the domain, finding the graph of the function. Looking at my graph, can someone tell me what the range is? Or Robert? Robert, what did you say the range was?
Just bracket 0 on the-
Perfect job. All right. Now I guess you get a free pass from writing on the board for a while. Any questions on example number 14? Okay. Now, again, I would focus on looking at the domain when we're doing questions. Of course, you can graph the function and find the range, but we will do a little bit more practice with graphing in an easier way later on. So definitely focus more on the domain we're studying. Okay. I guess if we're done this, let's move on to our next type of function. Okay. Remember, I said when we're finding the domain, there's 2 things that mess us up, okay? The first thing is square roots, okay, which we already talked about. The second thing are fractions or denominators. So whenever we have a denominator in a function, it restricts our domain, meaning that it's not going to be all real numbers, okay? So let's just take a look at this function. This is the, as we call the 1 over x function, which we'll talk about a little bit later. And this function looks a little crazy, okay? It's got these weird, this weird shape, and there's these things on this shape that we have a special name for. Does anyone know what these imaginary lines I'm drawing are called? Starts with an A. Asymptotes, right?
I did not say that. I said axes.
Oh, they are axes. Yeah, that works too. But yeah, what I drew were these things called, now that I gave it away, asymptotes. Okay, and does anyone know what an asymptote is? An asymptote, the definition of it in this class will be, it's going to be an imaginary line that the graph will get really close to, but it will never touch the line, okay? The graph gets close to, but it doesn't touch it. Okay, so imaginary line that the graph gets close to, but it doesn't touch. If you ever take a calculus class, the definition of an asymptote is going to change, okay? So if you ever take calc, the definition won't mean this. Okay, it'll be very close, but in calculus, the graph can actually touch an asymptote. But you have to take that class to find out examples of those. Okay, so all an asymptote is an imaginary line that the graph gets really, really close to, but it never touches it. So it kind of gets infinitely, infinitely close to this line. Okay, So when we do these asymptotes, does anyone know kind of how the asymptote comes about? Like, why is this 1/x function never going to touch the line x equals 0? Well, what happens when I plug in x equals 0? Right, f of 0 would be 1/0. And if you type that in your calculator would explode, right? No, it wouldn't, but it would say error, right? And this wouldn't work. Okay, so the big idea behind a denominator or a fraction type function is the denominator can't be equal to 0. Okay, I'm actually going to write this out. Okay, denominator cannot be equal to 0. Okay. I do have some stuff written down. I'm not really going to read it just because I don't find writing things out very helpful in sentences and math. So let's just go through an example and see what happens. Okay, so this is a very small example. Instead of the function 1/x, we have the function 6/a. When we find the domain, we take the denominator and set it not equal to 0. Okay, so we're going to put an equal sign with slash, set it equal to 0. Okay. In this case, the denominator is just a. Okay, so a is not equal to 0. Well, that was easy. We don't have to solve for a. It's already there. So it looks like our x value can't be equal to 0, which means our domain is everything except 0, right? So if I were to graph this, okay, 0, 1, 2, -1, -2, I would have an open circle at 0, right? And actually, any other point would work except for 0. Any ideas on how to write this in set builder notation? Awesome. Mm-hmm. Okay. Uh-huh. Perfect, right? So in this case, we actually have 2 arrows, which means we need 2 sets of like parentheses, right? So we need -infinity to 0, and then 0 to infinity. And that just means that we're taking out that 0 since we have parentheses here. We're not including 0, okay? Now this U symbol, it's called the union symbol. And it literally just means the word and. Okay, so we're saying this set of points and this other set of points. Any questions on how I wrote my domain? I know it looks a little funky. In WebAssign, this is what you're going to see. Okay. Let's look at the range. And I conveniently graphed my function here to make it a little bit easier to see. Okay. Looking at this graph, what do you think the range is going to be? Can you think of any y values that wouldn't work here? Well, let's go to y equals 3. Actually, looking left and right, it looks like the function does have a value at 3, so 3 would work. Any y values the function wouldn't work at? Oh, look, I hear 0. Let's do -6 here. At y equals -6, if I look to the left and right, oh, looks like the function's there. But I heard someone say 0. Yeah, if I'm at y equals 0 and I look to the left and right, there's no function there, right? The function gets really close to y equals 0, but it never touches it. So actually, y can't be 0. Okay, technically I should be saying w, but I think we're good with layman's terms here. And looking at the rest of the graph, it looks like 0 is the only thing it can't be. Looks like the function exists at all the other y values. Okay, so how can I write this guy in function notation or set builder notation? Rob?
So basically, extension.
Yes, it's the same thing as I wrote, right? Because, well, why not equal to 0 is the same as something else not being equal to 0. So it's literally the same thing. Negative infinity to 0 and 0 to positive infinity. Okay. Any questions on example number 15? Oh, yeah. We'll actually see next class. It can be different, and I'll show you an example as to how, but I'll save that for next class. All right. If we don't have any more questions, then I'm going to let you out 3 minutes early. Have a great Monday and Tuesday, and I'll see you on Wednesday.